Clay McKinney, developer on-ramp, introduction to HTML. We're talking about web graphics. And in this video, we're going to talk about the GIF file format. That's the graphics interchange format. And let's see, I have this picture here. I'm going to see what it looks like as a GIF file. Okay, so I'm going to change it from a JPEG to GIF 32 no dither. And you can see that it flattens the color in my photo and just kind of posterizes it. So there's big flat areas of color everywhere. And so what's happened is the GIF file format, the main way that it does compression is it reduces the number of colors. So normally you would have 8 bits red, 8 bits green, 8 bits blue, but in the case of a GIF file, instead of having 24 bits per pixel to have 16.7 million colors, instead they give you a table where they take the colors that are found in the image or close to them, and they just reduce it to, in this case, since it's 32 colors, they make a color table that holds 32 colors. All right. Now, 32 colors is 32 choices is 5 bits. Does that make sense? Like if you have 1 bit, you have 2 choices. If you have 2 bits, you have 4 choices. 3 bits is 8 choices. 4 bits is 16 choices. And 5 bits is 32 choices. Right? So to make this table, you only need 5 bits per pixel instead of 24 bits per pixel. And that's the first wave of compression. Let's see, calculator. So this would be 500 pixels times 500 pixels times 5 bits per pixel. So it's 1,250,000 bits divided by 8 is 156,000 bytes divided by 1,024. It's 152 kilobytes. So that's the first wave of compression, but they don't stop there. You can see that this image is 57K and instead of 150K, right? So it's a third of what it would have been just by going to the color table. So the way they do the rest of it is with zip compression. They're just looking for horizontal rows of the same color repeated, and instead of using 5 bits each time to say, all right, give me a gray one, 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 right? They just say, all right, well, it looks like I'm going to need about 300 of them there gray ones, right? So that's how they do the rest of the compression with zip compression, just looking for patterns of runs of the same color. All right, so that's how it does the compression, and that's why it's not really good for photographs. With photographs, sort of natively, every pixel is different. So photographic images just don't compress very well. All right, but what GIFs are good at, several things. They're good at type, right? They're good at flat color logos. Because with a flat color logo or typography, you do your image naturally just has a few colors in it, so making it a color table is fine. And naturally, with those big areas of flat color, it compresses down really well. So typography is really good as a GIF file. Let me show you. Let me cancel that. Make a new file, 500 by 500, and we're going to write typography. Okay, and we'll make it big. Well, I'm going to have to find a different way to make it big. There we go. Typography. Okay, well, let's go to File. And all right, so what I want you to see is what this looks like as a JPEG. 1600. Okay, So on JPEG, you have the type, but then you have these weird, stray, weird things. And this is on high compression. And those are actually visible. Typography just doesn't look good as a JPEG. It looks especially bad on the lower settings, of course. So I'll show you that. Okay, yeah, see how the feet are getting all smudgy, kind of gross. Yeah, it's not good. It's not good. It's horrifying. Okay, so that's as a JPEG, Joint Photographic Experts Group, right? Those guys are really good at photographs, really bad at photography. But then you make this GIF. Ooh, crispy. Nice. Beautiful. And when you zoom in, it's so clean. All right. So these shades of gray around the edges, that helps these letters look round instead of jagged. It's called anti-aliasing, and that's a good thing. But these stray ones that are just out there being crazy, that's just the JPEG algorithm not having any idea what to do with an edge, right? Okay, so JPEGs are great for photos. GIFs are good at typography. GIFs also are good at animated GIFs, right? And they're also good at transparent GIFs. Let me show you how that works. I'm going to turn the background off. So now it's transparent, and save for web, and JPEG doesn't have transparency, but GIF does. Right? So we could put this on a web page, and whatever was in the background of the web page would show through this image. It's a really neat trick. There's a limitation. The transparency here is either on or off. There's no in between. Right now, the anti-aliasing is assuming that this is going to be on a white background. You can see the matte here. If we told it that we were going to put this on a red background, now it's anti-aliased to red. So that's a limitation, is that you kind of have to know in advance what the background is, or it's going to anti-alias it to the wrong color. All right. So that's a limitation of GIF transparency, transparent GIFs. But still, GIFs support transparency, GIFs support animation, GIFs are good at typography. JPEG does none of that. None of it. All right. Next we'll talk about pings. Thank you.